Hi everyone, welcome to our next tutorial. In this circuit, we have a couple new components that we haven't talked about before. We've got a component here that's called a switch. And a switch is just like your light switch at home. Basically, all it does is when it's open, like this case here, it creates an open circuit and no electricity or electrons can flow. Down here, we have a symbol for a fuse. A fuse is a protection device for a DC circuit, and it will simply open up, or the fuse will blow if there's too much current in the circuit, or if the current goes above the fuse rating. So every fuse has a rating. So for instance, if this fuse is rated for 1 amp, then if the circuit current goes above that value, this fuse will blow or open, and it creates an open circuit, and when that happens, no current can flow. So if we were given this example here where this was a 20-volt DC battery, and if R1 had a resistance of 5 ohms, and if R2 had a resistance of 5 ohms, this is a simple series circuit. So we can determine the total resistance by adding R1 plus R2. So 5 ohms plus 5 ohms would give us a total resistance of 10 ohms. If I was to calculate the current in this circuit, I need to know the voltage and divide it by the total resistance. So the voltage in this circuit is 20 volts. The total resistance in this circuit is 10 ohms. So if I do the division, that gives me a current of 2 amps. Well, recall that the fuse rating is only 1 amp. So as soon as this switch is closed here, the 2 amps will leave the battery, and for a time 2 amps will flow till it gets to the fuse, and the fuse will blow, open up, create an opening here, and the current will stop flowing. So for an instant, there will be current flowing in this circuit until the fuse gets hot and actually starts to melt and break open. At that point, the current will stop. So that's how we use a fuse and a switch inside a simple series circuit. That's it for this time. Take care. We'll talk to you soon.